Okay, we're doing 15.7, which is conditions and properties of quadrilaterals. So we learned about a parallelogram and the properties that go with a parallelogram. So because it has the word parallel, we know that opposite sides are parallel. So both opposite sides are parallel. We also know that both opposite sides are congruent. So we can mark both opposite sides congruent. We know both opposite angles are congruent. So both opposite angles are congruent. And consecutive angles are supplementary. So if you put in x and y, we can say that angle x and angle y should add up to 180 degrees. And then finally, we know that the diagonals bisect each other. So these two pieces are equal and these two pieces are equal. All of this was from 15.6. We're going to talk about the different special parallelograms. So if we have our parallelograms from up above, these other shapes are also parallelograms, but they have extra properties that the parallelogram itself doesn't just have. So let's dive into what a rhombus is. So a rhombus is a parallelogram, but it also has four congruent sides. So not only are the opposite sides congruent, but all of the sides are congruent. Also, the diagonals are perpendicular. So not only do they bisect each other, but the diagonals create a right angle. They are perpendicular. And then finally, the diagonals bisect the angles. So not only do they bisect the segments, but the angles are going to get cut in half to create two congruent pieces on each side. A rectangle is a special parallelogram where we have four right angles. So in a parallelogram, we don't really necessarily have right angles, but if you have four right angles, it's a rectangle. Also, the diagonals are congruent. So they're bisecting and they're the same length. Therefore, each of these pieces is equal. So if you put a parallelogram, rhombus, and rectangle, and combine all of it together, we get my favorite shape, a square. Because a square has every single property that's above it, every single one. So a square is going to have four right angles and four congruent sides. So that makes the square the most special shape of all because it has all the properties. So it says determine whether each quadrilateral must be a rectangle. So remember what a rectangle is. It's a parallelogram that has four right angles and the diagonals are congruent. So notice this is a parallelogram because opposite sides are parallel. We do have one right angle, and we know in a parallelogram, opposite angles are congruent, and we know that consecutive angles are supplementary. So if this is 90, this has to be 90 to add to 180. And then opposite angles are congruent, so that's 90. So notice we have four right angles, therefore we can say this is a rectangle because it's a parallelogram with right angles. For part B, we don't have any right angles marked, and we don't have any information on the diagonals. It looks like a rectangle, but nothing's marked like it should be. So we don't have enough information to say that this is a rectangle, so we can't say that. And in C, I don't have my right angles, but notice the diagonals are congruent. So yes, this is a rectangle because the diagonals bisect each other and are congruent. For number 2, each quadrilateral is a parallelogram. Determine whether each parallelogram is a rhombus. So we're going to look at the properties of a rhombus and see if we have anything over here. Notice we have opposite sides are parallel, so it's a parallelogram. And we have a right angle where the diagonals cross. So when you have right angles, that is a property of a rhombus. So yes, this is a rhombus. It's a parallelogram with diagonals that are perpendicular. For B, Notice the diagonals are not congruent, but they are bisecting each other. But then notice that these angles are also marked equal, and that's a property of a rhombus where the diagonals bisect the angles. So therefore, yes, it is a rhombus because the diagonals are bisecting the angles. And then part C, notice opposite angles are congruent, so it's a parallelogram, but it doesn't have all four sides marked equal. It doesn't have anything about the diagonals being perpendicular or bisecting the angles. So we cannot say that this is a rhombus. We can just say it's a parallelogram. All right, for number 3, it says each quadrilateral is a parallelogram. Determine whether each parallelogram is a square. So a square could be a combo of the rhombus and rectangle, or it could just be that it's got 4 right angles and 4 equal sides. So looking at the picture, I have 4 equal sides. So this is a rhombus. But can I say it's a square? I need to have something from over here. Notice I don't have that. Therefore, I cannot say it's a square. We don't have any right angles to say it's a square. For part B, notice that I have the diagonals creating a right angle. Well, that is the property of a rhombus. And then notice the diagonals are congruent. Well, that's a rectangle. So if you combine properties of a rhombus and a rectangle, you get a square. For C, we have 4 right angles. So that is a rectangle. But we need something over here from the rhombus. We don't have 4 equal sides. We don't have anything about the diagonals, so we cannot say this shape is a square. Might look like one, but we need the markings to prove it. For number 4, give one characteristic about each figure that would make the conclusion valid. So if I want to say that this is for sure a rectangle, I can't just have one right angle. So remember what I need is 4 right angles. So I could say that angle A, angle D, and angle C are also 90 degrees. That would prove that this is a rectangle. Or remember, I could say that the diagonals are congruent. So I could say that segment AC is congruent to segment BD. That's another way to prove it's a rectangle. For part B, this time I'm trying to prove that ABCD is a rhombus. So notice I have the diagonals are bisecting each other. But for it to be a rhombus, I need one of these properties. So I could say all of the sides are congruent. So that would be segment AB, segment BC, segment CD, and segment DA are all congruent. I could say that the diagonals are perpendicular. So I could say segment BD is perpendicular to segment AC. Or I could say that the diagonals are bisecting the angles. So that would be angle BAC is congruent to angle DAC. So these two are equal. And then I have angle BCA is congruent to angle DCA. That would make these congruent. All right, number 5 says determine which quadrilateral match the figure. A parallelogram, rhombus, rectangular, square. List all that apply. So we are given the measure of angle WXY is 130 and angle XWZ is 50. And then the measure of angle WZY is 130. So notice we have opposite angles are congruent, consecutive angles are supplementary, so we can say it's a parallelogram. I can't say that this is a rhombus because none of the sides are marked equal. It's definitely not a rectangle because we don't have right angles. And since it's not a rectangle, it's also definitely not a square. So this is just a parallelogram. Number 6 says to classify the special quadrilateral, explain your reasoning, and then find the values of x and y. So we have 4 equal sides and 4 right angles. Therefore, it is a square because you have 4 right angles and 4 equal sides. So to solve for x, notice this side has an x of 5x minus 4, and this side has an x of 3x. Notice they are marked equal, so I can set 5x minus 4 equal to 3x. So to solve for x, I could subtract 3x from both sides. I get 2x minus 4 equals 0. Add the 4 over. That gives me 2x equals 4. Divide by 2, I get x equals 2. To solve for y, that's this angle right here. And remember, we said this is a square. So that means that the diagonals are perpendicular. So this 2y minus 10 should equal 90 degrees. So it's perpendicular. So to solve for y, minus the 10, I get 2y equals 80. Divide by 2, I get y equals 40 degrees. And then for b, notice all of the sides are marked equal, so it's a rhombus, but we don't have a right angle, so this is just a rhombus, not a rectangle or square. And the reason is 4 equal sides. So to solve for x, this angle has an x, and this angle is another one. Notice these angles are not opposite angles. These are consecutive angles. That means that these two angles will add up together to equal 180. So if I combine like terms, a negative 1 plus 127 is 126. Subtract the 126 over, I get 2x equals 54. Divide by 2, I get x is 27. To solve for y, notice this side has a y and this side has a y. Those are marked equal, so I can say 6y minus 5 equals 3y plus 7. Minus the 3y, I get 3y minus 5 equals 7. Add the 5, 3y equals 12, and divide by 3, I get y equals 4.